Hello there, I'm Thomas Hatsios, German American pilot flying the Boeing 787-900 tonight's flight from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport, runway 1449, Lszh localizer landing. So now I'm in the cockpit for the pre-takeoff preparation of the quality wings Boeing 787-900 and Microsoft Simulator X. I'm going to start showing you the cockpit instruments and the displays and the functions of the Boeing 787-900 aircraft. I'm going to start with the primary flight display. The displays the airspeed indicated, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the barometric pressure of the outside atmosphere, the target altitude selected from the autopilot flight director system panel, the vertical rate of climb descent of the aircraft in 10,000 feet per minute, all the steepness of the two barometric angles in decrease, you can climb and descend. Also we have the artificial horizon, the altitude indicator, the pixelatore decrease and the bank angle in decrease. The Lszh localizer, we have the horizontal localizer that receives the radio frequency antenna frequency transmitter from the runway we use for takeoff and for landing, the antennas in the threshold of the runway of the instrument landing system, the Lszh localizer, and they are received from the onboard antennas of the aircraft. And this way it aligns with the horizontal localizer, so we can use the magnetic north pole heading of 136 degrees of the runway 14 in Zurich International Airport, Lszh in Switzerland. So you're gonna see how I'm gonna use the Lszh localizer and the other systems of the cockpit, like in the primary flight display. Also we have Lszh localizer, horizontal and localizer vertical glide slope for the vertical glide path, and also the Lszh localizer crossbars, the flight director crossbars for manual guidance of the aircraft, and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies in the flight mode and non-zero with the autopilot and the auto throttle, lateral and vertical navigation modes. We have also the HSI, that displays the horizontal situation indicator, the magnetic heading and track, and also the integrated display of the flight plan. When we're gonna create a flight plan using the flight management computer, you're gonna see the purple or magenta line with the star waypoints displayed in the HSI, also in the navigation display. We have also the ADFs and also the wind direction and speed. You're gonna see when we're gonna be flying. We have also the navigation display that displays the horizontal vertical profile of the aircraft as it flies. You can see the terrain and weather reflections from the weather radar. You can see the red, green and yellow reflections of the terrain around you. You can see the terrain map. We have the magnetic north pole and the geographic north pole, magnetic variation depending on where we are on the world. You have the distance range in nautical miles. You can see the terrain map. Also you see the colors red, green, yellow. You can see the sea, river and lakes with blue. You can see also in the terrain map we have the airports with the 4-letter ICAO name, like our own airport, and the runway we're gonna use for takeoff and for landing, the taxiways, the other runway, and the runway length. So we have also, you can see how far away the other airports are. You can see the work stations, the ADFs, the NTPs, the navigation aids, the nav aids that we're gonna use. Also the waypoints which are horizontal and vertical navigation fixes. The aircraft we're gonna have to transverse through some as it flies, so I'm gonna select a few waypoints later using the flight management computer. When I'm gonna create the flight plan, you're gonna see again the flight plan we created, the route or flight path of the aircraft with a purple magenta lines, legs from one waypoint to the other, and also you will see horizontal vertical profile as we're gonna be flying here. So this is the horizontal display and this is the vertical. You're gonna see the aircraft here, how far above the ground it's gonna be. Right now it's positioned here in the terrain, so when it's airborne you will see this triangle moving around. You can see also the horizontal change direction, and we're gonna be flying. We're gonna reach some GPS symbols like the waypoints when we find the runway we're gonna use for takeoff and for landing. So you're gonna see also you can see we have the autopilot flight director system panel over here, the ACAS, the engine indication crawler system display, The flight management computer over here I'm gonna use to create a flight plan. You will see how I'm gonna make the inputs over here. You can see we have also the mouse pad for the flight management computer, so you will see later I'm gonna use the flight management computer. Here we'll see the colors here, the purple that shows you what symbol and what mode should I choose here using the mouse pad. So you will see later when I'm gonna create the flight plan, also the other keyboard functions. We use this mouse pad. You can also control over here these displays with the mouse pad. You can select things like this. Also the systems later, you will see here the systems of the aircraft we have in the overhead panel, like the electric, hydraulic, fuel, left and right wing fuel tank, center tank, fuel system, electronic engine control for the engines, pressurization, oxygen, and cabin pressurizer for the pack system. So you will see all the systems later. Also the flight controls, primary flight control computers, flight control surfaces, you will see later. Also in the display here where the engines are displayed right now. So you can see the left and the right engine indications, the symbol, and one exhaust gas temperature, and you can see the flaps, stabilizer trim, rudder trim over here, cabin altitude. Here's the cabin pressurization, the outflow valves, rate of climb, descent, differential pressure, the altitude. You can see gross weight of the aircraft here, 358,600, and the total fuel on board 35,900. Fuel temperature right now, the saturated air temperature. So we have many things to show you. Also the thrust levers here. You will see how I'm gonna use the thrust levers. So I can control the thrust produced by the engines like this. You can see here the engines. Maybe I'm gonna show you later. Also the flight controls. I'm using the flight controls, the elevator, aileron spoilers. So use the elevator for climb and descent. Also the control wheel for making bangles left and right. The rudder pedals for the vertical rudder. The thrust levers here, the flaps and the speed brakes. The fuel control, left and right engine fuel flow. Left and right engine fuel flow. The thrust levers, stabilizer trim cutoff switch, and alternate trim switch for the stabilizer. Also parking brakes, radio communication panel over here, the fire extinguishers for the left and the right engine pull out and switch, the transporter over here. Also you can see you can select the navigation radius here, or air traffic control, the frequencies, active and standby. So I'm gonna show you all the systems of the aircraft before we're gonna make a flight. In the end part of the video you will see the flight. So I'll make first the explanation of the systems one by one, then we're gonna see the flight. So I'm gonna show you now the outside view of the aircraft, and I will explain a little bit about the aerodynamics of the aircraft as we fly, the Newton's physics and the theory of fluids, aeronautical engineering and aerospace engineering principles. Also we need for the air transport pilot license. So you need to know the basics flight principles. So you can see here the outside view of the aircraft, also the airport we are located. So you can see again over here. So I'll talk to you about aerodynamics right now. You can see the surface area of the forward wings hold the weight of the aircraft when we're gonna be flying. You can see we have the thrust vectors from the engines to move the aircraft forward, the jet blast from the engines here coming backwards and push the aircraft forward. We have the mean aerodynamic chord position, the Mach, which is about 23% of the mean aerodynamic chord of the forward wings, is where the maximum aerodynamic lift occurs in the forward wings. It's also where the stall will begin all the way back The airflow will become detached for a given angle of attack when we fly, and we're gonna lose the lift from the wings, so the aircraft's gonna be falling. So we need to avoid the stall during flight all the time. Also, it's the center of pressure here, moving forward or aft. Also, where the main aerodynamic chord where the maximum aerodynamic lift occurs in the wings is where usually is the center of gravity of the aircraft, the vertical axis of the aircraft. So we have also the lateral axis from wingtip to wingtip. The lateral axis is the pitch axis of the aircraft. So you can climb and you can descend the aircraft around. The vertical axis is the yawing axis, and the longitudinal from nose to tail. Also the horizontal trim stabilizer and the elevator through the pitch axis. So we have the roll axis over here. We can roll the aircraft like this. So the roll axis is the longitudinal. You can make turns using the ailerons and the spoilers like this. Also when we retract, maybe see better. This is the roll axis, left and right turns of the aircraft. So this is the elevator axis, climb descent over here. The pitch axis, the lateral axis, as you can see. Now we climb. Now with descent, you can see the deflection is proportional to the yoke of the flight control surface. Also the yawing axis over here, the vertical axis that traverses the center of gravity for making left and right turns. So you can turn in flight using the ailerons and the spoilers. So we have also, you can see here, when we climb or descend, we use the elevator. So you balance also using the horizontal trim stabilizer, I will show you later. So you can see also from the wings, we have the bottom surface of the wings. When we flying, the airflow is moving faster below the wings. Since you can see. So you can see the bottom surface is more flat. Also we have the flaps extended. Also when we're gonna be flying, the aircraft is gonna having a positive angle of attack mainly, as when we climb or will cruise. So the airflow is moving slower below the wings using the Bernoulli theory of fluid, unless we descend. So we have higher pressure below the wings, which pressurizes the aircraft wings up into the air when we accelerate for takeoff, like 140 knots, 150 or higher. We have enough lift force from the wings, so it pressurizes the aircraft weight and wings up into the air. Also both wings. So we have the top surface of the wings, you can see, is more curved. So when we're flying, the airflow is moving much faster above the wings. So this creates a lower pressure above the wings, which sucks the aircraft wings and wake up into the air as we're flying. Also, you can make bank roll turns here. So this is the flight controls, the axis that we can use for flying. So I will show you now inside the aircraft how I use the flight controls of the Boeing 787. So I use the control wheel and the control column for climb and descent, the control wheel for making left and right turns, and also the rudder pedals for the yawing turns or the yawing axis. So we can climb and we can descend, as you see, using the control column. You can make turns left and right, also the rudder pedals. So you can see we can climb and we can descend, we can make turns to the left using the control wheel. Here is to make left and right turns, the control wheel, and also the rudder pedals for using the rudder to make turns in flight. Also we climb and descend, as you can see, using the elevator only. So I use the control stick for climb and descend like this. So you can see how many degrees you can climb, and you can see the side stick deflection is proportional to the yoke deflection. Also you can see both sides, the captain and the first officer, are moving together. They are interconnected in flight. Unless we have a failure, we don't have the side stick priority like in the Airbus aircraft side stick. So you can see the yoke I'm using, the side stick I'm using for controlling the flight controls here is controlling the yoke. This is flight by wire also aircraft, as you can see. When you move the side stick in the air, the yoke actually, or rudder bellows, you give you give orders to the flight control computers over here, primary flight control computers in the auto position. So it's like in the Airbus you have the normal, alternate, and direct blow of flying. So you use different level of flight control of control computers, or indirect you have the mechanical linkages for many flight control surfaces. So in the flight controls, fly by wire system, flight control computers, you have the flight control computers control how many degrees the elevator will deflect up or down for climb descent. Or you have the auto trim function. Also you have the automatic trim, you have the manual trim over here switch, so you can also know how to trim the horizontal tail of the aircraft when you fly. And you have also the alternate trim channel, and you have the automatic trim, so you can trim the horizontal tail elevator in flight. You can see this surface we move using the side stick or the yoke. You have also the trim switch inside the cockpit of the Boeing 787, so you can also trim manually. And you have the automatic trim for this surface. On some aircraft is the whole elevator that is trimmed up and down, the whole maybe the whole stabilizer. So you can see here we have the manual trim switch over here. So you have the elevator trim switch here, left and right. So this way you trim the nose, you trim the elevator to pitch the nose up, and this way you trim the elevator to pitch the nose down as you fly. So you can use the pitch trim as you wish to balance the aircraft. You can see elevator trim switch over here. So this way you trim the elevator to pitch the nose up like this, and this way you trim the elevator to pitch the nose down. You have also the head up declutter switch, the flap limits also not related to that, the autopilot disconnect over here, so you can see a few more details of the aircraft here. So we have here, as you can see, we have the auto trim system, we have the autopilot flight director system panel, the thrust levers, the auto throttle, and the flight control computers here. When we fly, we have the auto trim functions, and it's flying by wire aircraft. It trims itself automatically when it flies, unless we want to trim it manually. We use the trim switch that I show you in the control wheel. Or the alternate trim. Also we have the hydraulic system that controls the horizontal elevator and stabilizer over here functions, and the other flight controls movement. All flight controls are moving with hydraulic fluid pressure, as you can see, are actually hydraulic. So if you have a failure that affects the elevator, the auto trim will gonna have a malfunction. over here from the autopilot, flight control, flight monitoring here. So whatever, you will have to come here and open this guarded switch, the red guarded switch from normal, to cut off stabilizer, all L2 or R2, either one or both, if you have both left and right failure elevator. So from normal to cut off, and you lose the automatic trim function. Maybe you lose a few more controls, or maybe the autopilot is lost like this, but you have the alternate pitch trim. As you can see here, you can trim up the elevator or down, and pitch the nose up or down this way. So nose up, you pitch the nose up as you fly, and this way you pitch the nose down. So you select how much you need. You can feel it when you fly. From the flight controls is more convenient when you trim the right way the aircraft as you fly. You can fly on its own, straight and forward. You have also the manual trim all the time here. So this is for all Boeing 737, 747, 757, 767, 777, and Boeing 787 aircraft from normal to cut off. And you have the alternate trim channel of the flight control computers and the manual, both manual trim switches. So you have the elevator again. I'll show you the rest of the flight controls now, a few more details. So you can see the elevator trim, stabilizer trim over here, nose up or nose down, 4.25 degrees right now. You have the rudder trim also, the flaps position over here, secondary flight controls. So you can see the flaps, how many degrees. It's also part of the flight controls. They increase the surface area of the wings. They allow you to fly at lower airspeed for approach and landing or for takeoff. Over here you can see how many degrees, like 17, 18, more up, 5, 10, 20, 25, 20, 20, 25, 30 over here. So if you set it up like this, you will see it's moving up. The flaps position will be moving up here accordingly. You can see it's moving up. When we set it down like this, you will see the extent all the way up. You can see how fast they move. Also you can see the flaps now movement over here of the extent. Also we have the speed brakes over here. You can retract, you can extend the speed brakes, which is also part of the flight spoilers system. So you have the flaps over here, fully extended almost, like this. You will see fully extend right now. We have the speed brakes also that I saw you. We have other controls also. As I told you, the engines over here. We have the landing gear displayed here, extend and retract. This landing gear, alternate gear if you have failure of the normal, lock override, the retract speed, standby display instruments. Over here we have also the auto brakes system here for executive takeoff or manual for landing. This arm, it will display like RTO like this, auto brake RTO here in the ACAS, or auto brake 1 for landing. We cannot arm it right now, so it's off. So also your controls of the aircraft. I told you the thrust levers, left and right engine. We have also here the auto throttle disconnect switch here. You press this switch, you disconnect the auto throttle, as you can see. Auto throttle disconnect, throttle control, and takeoff go on. Also we have the thrust reverse, you will see later. And the fuel control, as I told you, left and right engine. So a few more flight controls right now, then I will show you the rest of the systems. So I will show you this side view of the flight controls also. I control the elevator, aileron, spoilers, and rudder pedals. So in the rudder pedals also we have the function of the rudder, the vertical tail. Rudder, also we have the nose wheel steering, the tiller, the forward nose wheel steering in the ground from like 0 to 70 knots is active, is decreasing from 76 decrease deflection left and right, the forward nozzle to down like 7 degrees at 40 knots in takeoff, then it decreases from 40 knots to 80 like or 70 knots, it decreases from 7 degrees to like 0. So you have only the rudder after for takeoff for directional control. So the rudder is aerodynamically effective like 45 knots airspeed in takeoff. So you will see the rudder pedals when I control. I have also the input from the tiller for the nose wheel, as I told you. I have the rudder, vertical tail, and I have you can see the rudder here, the vertical tail function, right and left. So this is the rudder pedals over here. You see the rudder pedals. So we have also the toe brakes in the rudder pedals. So it's many controls you have in the yoke, horizontal trim stabilizer, elevator like this. You can climb and you can descend, and ailerons and spoilers like left and right turn. So you will see now this view of the flight control system that I told you. Or you will see a little bit better the flight controls. Maybe the view of the cockpit. So you can see I can use the side stick for climb and for descent to control the yoke over here of the Boeing 787 or the flight control. Maybe better view now of the screen. So you can climb, you can descend, you can also make turns in the air. So I hope you like the side stick I use, the Lszh Extreme 3D, like this. You can see I have also the thrust levers here. You can control the engine's thrust forward and aft, the engine's function. So we can climb, as I told you, we can descend, both sides are interconnected, the captain and the first officer move together, side stick deflection is proportional to the yoke deflection, as you can see. So you can see how fast it's responding to changes of the flight control movement. So it's the same in the air. So I will show you now the rest of the systems of the Boeing 787. You can leave neutral also, you can use all the thrust levers, as I told you over here. You see the thrust is moving here, up or down, forward or aft. So this is the thrust control, and the horizontal trim stabilizer control over here. So you have many control functions using the side stick, Lszh Extreme 3D like this. Have also the outside view. Turns left and turns right, rudder pedals, elevator, climb, descent, bungles. left and right. So this is bunk rolls, left and bunk rolls right. Elevator climb and descent. Speed brakes extended. So this is so much for the flight controls. I will show you the rest of the systems of the Boeing 787 right now. Yes. So you will see now the rest of the systems of the Boeing 787 aircraft. We'll continue now with the engines functions, and also the flight management computer. I will input the data of the aircraft for this flight. So I will input the takeoff gross weight that includes the empty weight plus the passenger plus the cargo plus the fuel on board, where the fuel is stored in the left and the right wing in the center tank. The flight management computer is going to calculate automatically the center of gravity of the aircraft and the minimum dynamic chord position for takeoff the Mach, which is 23% of the minimum dynamic chord of the forward wings. As I told you, is the position where the stall will begin as we fly for a given angle of attack and airspeed that is changing. So as we fly, we burn fuel. The flight management computer is going to recalculate the center of gravity of the aircraft as we burn fuel. The center of gravity is shifted. Also, you can monitor over here the stall speed. In the primary flight display, you can see the airspeed. Over here, the airspeed tape, the stall speed is gonna be displayed down here of the red yellow. You can see the altitude, airspeed selected, altitude selected, vertical rate of climb, descent, pitch ladder, and bank angle. The basics. So I'll show you later after I set up the flight management computer, the flight plan. So I use the left and right wing is going to be calculated how much fuel we have. 30% in the left and 30% in the right wing tank, 10% in the center tank. The flight management computer, as I told you, calculates the loads. So we're gonna have the center of gravity, the minimum aerodynamic chord position of the forward wings, and the horizontal trim stabilizer for takeoff. With the center of gravity is gonna be 4.35 degrees. Pitch up, and also we're gonna be having 15 degrees, 15 degrees of flaps for takeoff, 9 degrees of pitch attitude or less, as we're gonna be taking off in the runway with about 140-150 knots for rotation and takeoff. So you will see we're gonna use the runway for takeoff. We're gonna select it using the flight management computer. It's gonna calculate the runway length, the runway slope, the wind direction and speed, the barometric pressure, the density of the air, the temperature of the air. Also the runway conditions, if we decide dry or wet, is gonna give us the takeoff speeds V1, V-rotate and V2 automatically. So we're gonna have a V-rotate of 130 knots, a V2 about 140 knots. So we're gonna be having the flight management computer. Also, I'm gonna input the seeds. The seeds are the southern instrument parts, waypoints, and fixes that include horizontal, vertical navigation fixes and altitude and airspeed constraints for the initial climb of the aircraft after takeoff. You will see them also. Also, we're gonna select the cruise level. We're gonna cruise like 25, 26, 27, 28, 29, 30,000 feet above the sea level. We're gonna cross through some waypoints, then we're gonna have the top of descent. We'll initiate the descent of the aircraft back to the airport elevation, like 7 or 6,000 feet above the sea level. The airport is like 1,430 feet above the sea level. This is the Zurich International Airport, Lszh, it's in Switzerland. So we're gonna have the stars for this airport and the runway 14 in Zurich International Airport, both for takeoff and for landing. We're gonna select the same airport and the same runway. Let's say it's in Switzerland, runway 14. So we're gonna have again the stars, the southern terminal arrival waypoints and fixes that include horizontal, vertical navigation fixes and altitude and speed constraints for the terminal approach and landing of the aircraft, for the long final and short final approaches. Also the Lszh localizer, as I told you, have the instrument landing system. The Lszh localizer of the runway 14 of the Zurich International Airport, Lszh, it's in Switzerland, is gonna transmit the radio frequencies from the runway threshold antennas. You will receive it from the onboard aircraft antennas. You will see the horizontal localizer, the vertical glide slope as we're gonna be approaching the landing. So you will see we're gonna be aligned with the magnetic north pole heading 136 degrees of the runway 14. So we're gonna have also a pitch altitude of 9 degrees for approach and landing, about 25-30 degrees of flaps, and airspeed 160-170 knots, and the landing gear down. So you will see the complete flight in the end part of the video. Also, we're gonna have a complete flight plan or flight path or route using the flight management computer here. So I will show you now how we'll create one using the flight management computer. So again, you see the mouse pad here, the keyboard, and the flight management computer, the screen that I have to control the flight management computer functions here. So I can control either mode over here. You will see the purple line box moving up and down in the cursor of the mouse. So I can select identity. You will see identity is model 787-900 GNX engines. Index position here, we will use Lszh, Zurich International Airport. He will give us the GPS position. For this, we will align if we need GPS position, set inertial alignment also. So we have many modes. We have performance, takeoff, approach, annunciate status over here. Also navigation data, flight plans, load the traffic route, load plan, save flight plan over here. So we use first the performance of the aircraft, 0 fuel weight plus fuel on board, gross weight. We're gonna set the cruise altitude, the cost index, minimum fuel temperature, freezing temperature, size and center of gravity, reserve. So we're gonna set the route first. Lszh, Zurich International Airport, Switzerland. Again, Lszh departure arrival over here. Copy paste like this. So you will see runway 14 again, takeoff and landing. We'll use departures now, departures and arrivals over here. So we set the departure runway. We can select runway 10, 14, 16, 28, 32. The right side is selecting the runway, the left side selects the seats, the other instrument departure weights points are fixed. So we'll select runway 14, transit to Alpha. So we'll select departures arrivals again. So now it's the arrival. We can select VOM 16, 28, 34, ILS 14. The runways we can use for landing: ILS 16, instrument landing system 28, 34, ILS 34, GLS 14, localizer 28, localizer 34, and this is the stars we can use on the left side. So we select runway ILS 14, Transamity, and the stars, the starter terminal arrival waypoints and fixes. We're gonna use the Negria 1 Alpha over here. So you can see the starter terminal arrival waypoints and fixes, ILS 14 approach and Transamity. So we have now the legs from takeoff. You can see the distance from one waypoint to the next one, the heading. We're gonna change direction in flight, the altitude and the airspeed we will be traveling. So we have the Zui here. Next we have Nigria, Mati, Vamiki. We're gonna be flying here the cruise level, then we're gonna descend ZH, TRE, Osnem C114 here in runway 14. So we use the initialize on the performance here to activate the flight plan. You can see the flight plan is with blue. Over here is not yet active. It needs to be with white and purple. So we will use here the 0 fuel weight for takeoff, 322.7 thousand pounds, fuel on board 33,700, gross weight 356.4. So we have reserves for this flight 5%, cruising altitude 25,300 feet over here. You will have the cost index 100%, fuel freezing temperature over here minus 37 degrees. So the fuel will freeze in flight at minus 37 degrees. So we need to recirculate it in flight, and the center of gravity is going to be 28%. So when we press this green pattern here, the execute, it will activate this route. So we have the first waypoint 136 degrees, 250 knots, 1900 alpha. Then we change direction 096, 1 nautical mile, 096, 3 nautical miles, 014, 5 nautical miles, 052 is Zui, 6 nautical miles, 301 knots, 6000 alpha. You can see we climb here from takeoff Negria 071, 26 nautical miles, 301 knots, flight level 22,200 feet, motive 230 knots, 230 degrees. We made a right turn, 12 nautical miles from Negria, 320 knots, 11,800. So we started the descent here for approach and landing. Hameki 258, 6 nautical miles, 190, 10,400. Zurich 276 degrees, heading 9 nautical miles, 180, 7,000 alpha. Z8701, 290 degrees, 6 nautical miles, 180, 6,000 alpha. TRA 290, 10 nautical miles, 180, 5,000 alpha. C114, 6 nautical miles, 180, 4,000 alpha. Ulsloc 5 nautical miles, 174,000 over here. Runway 14, approach and landing 8 nautical miles, heading 136 degrees. So this is the complete route. We use also flaps 15 degrees. Over here is gonna give us the center of gravity for takeoff. Over here automatically in the takeoff speeds, as you can see, takeoff reference. So a few more things to see over here before going to flight. So this is the complete route, takeoff legs over here, initialize, route departure, alternate. We have a few more functions: alternate flap, flight plan, VNAV, progress, FMC communications, hold. We can hold over waypoint in flight, fix, and navigation radio. We can tune the radios automatically like a localizer. So this is all we need to do using the flight management computer. I'm gonna have a different display now. In the displays here, you can see for the display, you can see we will look further away. You can see here we have the Germany, we have the France, all these airports, the names of the airports, the distance. This is a 160 nautical miles right now. The range, ground speed, magnetic North Pole heading, very severe terrain. 0481016 is maximum and minimum displayed with red and yellow. As we're gonna be flying, you can see the vertical also as we're gonna be climbing and cruise through some waypoints. So you will see the flight plan now I'm telling you about. We can use this switch to change the range over here. You will look closer, you will see the stars displayed here, approach and landing over here, this purple line on this runway. Also this is the takeoff, both takeoff. You can see the climb here, the terrain in front of you. This is the vertical and this is the horizontal map. This is the vertical. As we fly, you can see the terrain we have to avoid as we fly. You can see the AME key over here displayed. So this is the complete flight plan here, how far away we will be flying. Also the center display here. So this is for navigation purposes, the flight plan we're gonna use. You can see also a closer look over here. You can see the runway we're gonna use for takeoff and for landing, the taxiway in front of us, the other runway, and the terrain in front of you. As you're gonna be flying, you have some mountains here, so we need to avoid. You will see how far above the ground we will be flying. You can see the mountains in front of you here. You can see the taxiway, the runway we use for takeoff and for landing. So this is what it displays in the GPS and the terrain map. So also, you know, as much as we're having a little bit more time, the plan here also display. You can see the plan displayed, how far away we'll look over here again, the waypoints as we're gonna be flying. You can see how far away we're gonna be flying over here. So this is the complete flight plan from takeoff over here, climb, cruise, descent, approach and landing. As you change the view over here, look further, closer, you look better. So this is takeoff here, the runway we use for takeoff, one waypoint by another. Also you can see again the runway, better view here. Also the map salary over here, map salary. So this is the navigation displays. You can use also this view as I told you. So you can see the airspeed indicated, the barometric altitude, the vertical rate of climb, descent of the aircraft. Here this needle will move up when we climb, down when we descend, radio altitude, pitch ladder in decrease, bank angle in decrease, line mode annunciator, also airspeed and altitude, barometric also. It's a side here, displays again. So this is the flight plan here created, the legs. So we'll select over here autopilot, flight director, system panel, autopilot engage, disengage, auto throttle, over here airspeed. Select the airspeed for takeoff. So you can see we have flight director, LNAV and VNAV. Flight director on off. So we set the LNAV, auto throttle. So a few more displays, bank angle, autopilot disengage in flight. So we'll select the heading over here, magnetic north pole heading. The altitude over here, set the altitude. You can set higher. So we set also hundreds. And also we have the vertical speed. So this is the airspeed guidance, LNAV, VNAV function, flight level change, climb continuous, auto throttle, heading, hold, and vertical rate of climb descent. Autopilot, flight director, system panel, zeros over here. You can descend like this. Also you can climb the other way like this. So you'll see also the engine's indication here, N1, as I told you. So this is the N1, which is the low speed status, have low pressure compressor and turbine of the turbofan with the engines. So we have the FAREX control the engine's functions and displays in the ACAS and indication equivalent system display like the N1, which is the low speed status, have low pressure compressor and turbine of the turbofan with the engine, exhaust gas temperature current, N2, which is the high speed status, have high pressure compressor and turbine of the turbofan with the engine. Fuel flow currency per hour, 1000 kilograms, 1000 pounds, oil pressure, oil temperature, oil quantity, and the vibration of the two stages of the engine. Also the FAREX control as we climb or descend into higher or low altitudes, the fuel air mixture adjustment, because as we fly higher like 20, 30 or 40,000 feet above the sea level, like 8,000, 9,000, 10,000, 11 or 12,000 meters above the sea level, the pressure of the air, the density and the oxygen level become less than half the that of the sea level. Also as we climb higher, the temperature is decreasing, minus 20, minus 30, minus 40, minus 50, minus 60 degrees below 0 Celsius. Also the aircraft will be flying with an airspeed rate like 2 or 3 times faster than that of the sea level. So as we climb higher, the FAREX, the full authority, these electronic control computers, one installed per engine gearbox, one in the left wing, one in the right wing, engine, dual channel redundancy, one channel phase, the other takes over. So it controls all the functions that I told you. Also the fuel air mixer, as we climb higher, we have a higher intake of air from the front fans, so it's adjusted automatically. Also as we descend back to the airport elevation. Also the FAREX control the pressurized air from the 5th and 9th stage of the engines. Also hydraulic fluid air pressurizer for cabin pressurization. Also the wing, the left and right wing tank, fuel tank, fuel recirculation is automatic. We recirculate the fuel in flight so it will heat up, so it won't freeze. Also the oil and the lubricant of the engines is recirculated in flight. So you'll see now over here pressurized air. So we have a few more minutes to go for flight. We'll start the APU here. So this is electric, 120 to 100 volts, 400 Hz frequency, left and right engine drive and IDC. Primary flight control computers in the auto position. Air data computer, I'll talk to you later. Flight control surfaces over here. Towing power, FD door, oxygen, passenger oxygen here. Window heat, rammer turbine, left and right engine, hydraulic in the auto, engine driven and electric driven. You can see what happens, the fault indicates here, so we turn them back on. The hydraulic pumps. We have also the rammer turbine as a standby and electric driving. So we have here the recorders, cargo and APU fire over here. electronic engine control for the engine, normal and alternate mode, and the auto start here. As you can see, auto start fuel jettison. We can dump some fuel in flight. We select this and how much to remain in the nozzles. Also left and right wing fuel tank, center tank, fuel booster pumps. The crossfit valve is off, but with turn it on can feed either engine with either pump or either tank, and balance the fuel between the left and the right wing tank. We have the pressurizer from the left and right engine from the APU, also the packs, passenger oxygen, cabin pressurization. So we use the outflow valve, climb, descend in the manual. In the auto we need to do nothing, it's all automatic. So you will see also the digital display format of whatever I show you right now. So we have the digital display of all the systems here. So you can see we have the status, hydraulic, APUs running, oxygen, liquid cooling, electric, left and right engine, IDG, the controllers, APUs running, battery voltage over here. So you can see drive, contactors, battery voltage and average, and APU battery. Hydraulics, where the hydraulic fluid goes, how much hydraulic fluid you have in each tank, hydraulic fluid pressure 5100 psi, start of valves, demand and primary, engine, electric drive and fuel, left and right wing fuel tank, center tank 11,000, 11,000, 11,000, total 33,000. Both left and right engine when high pressure fuel valves are open and feed both engines from the center or the wing tanks. The APU is fed from the left wing is this moderate crossfit valve is off, but we turn it on can feed either engine with either pump or either tank. Also the minimum fuel temperature, we need to recirculate the fuel to the engines automatically. You can see it's minus 37 degrees, below which it freeze, minus 5 right now. The air pressurizer from the left and right engine from the packs, APU. Also the doors here are closed, the cabin can pressurize, the pressure of the tires and the pressure of the brakes, flight controls over here. So when you fly you see the flight controls movement, climb, descend, making turns over here. So you see flight controls movement over here, deflections, FS display over here, status, maintenance, system display, circuit breakers again. And we have the last one, the checklist over here, what to do, normal menu before takeoff, after takeoff, before start. So we go in the navigation display and we turn off both engines again over here, both engines to the off position. So you see the fuel flow is off, you see what happens, what it displays. We have the APU on, so you see the faults now. So we need to start the engines right now, auto start. Over here both auto start, left and right engine driving. You would see the reconfiguration, the yellow amber colors in the overhead panel. So we have the APU is admitting pressurizer right now. Above 20% we can start the fuel flow. So you can hear the roar here, the pressurizer to the engines. So we can start fuel flow both left and right engine, and we can go for takeoff after a couple of minutes. So we have pressurize, auto start, pressurizer, and fuel also right now. So we have also the temperature increase with the fuel. You can see the hydraulics will turn on the engines. So auto start here needs a couple of seconds, and we have all the yellow indications turned off. We can go for takeoff in a couple of seconds. So we have running both engines. So flaps for takeoff here, advance the thrust levers, and go for takeoff. So we're ready now. We take the clearance from the air traffic control here. So we only the runway is open for us. We use the tiller for alignment, as you can see, for steering. So we align with the center line. Thrust levers over here to the maximum takeoff power, and we go. As you can see, we have 50 knots over here, 80 knots. Align with the center line, use some rudder pedals. 120, V1, we rotate like a little bit 9 degrees over here. So we climb, muddy gear up over here. Use a little bit rudder to maintain the center line. So this is the initial climb of the aircraft. We have the positive rate of climb, as you can see. You can see all the indications here are correct. You can see the airspeed is 220 knots, the wind direction speed, we are 1,300, 400 above the ground, 2,900 above the sea. We climb 4,000 feet per minute, 3,400 above the sea, 2,000 feet above the ground. So you can see the terrain around you with green, also below you. You can see how far the aircraft is, like a couple of thousand feet, 2,000 feet above the terrain. It's keep climbing. You can see also the engines indications here, and a little bit further away, if you look, you will see more terrain displayed in the terrain map over here. Keep climbing. So you see now where we are as we climbed. Also the outside view. Now we have here the Switzerland over here, the lakes, the airport behind us, and the Swiss Alps. So we need to start the turn now for the flight plan, to follow the flight plan. So we keep climbing over here. You can see we can leave the flight controls off as we fly. There's no problem, we follow just the flight plan. We trim a little bit. Make a small turn. We need to follow all the flight plan lines here. So this is the view of the cockpit over here of the Boeing 787, just after takeoff over here. So we keep climbing. We need a few more minutes to climb to the cruise level, then descend. So hope you like the view of the cockpit just after takeoff over here. We keep climbing. We're gonna make a small flight as you see, and then come back for landing, manual flight as you see. So you can see the airspeed now, also the Mach speed 227 knots, 0.420 Mach, and we're cruising, we climb through 13,300 feet with 3,800 feet per minute. The target altitude, target airspeed, also the wind direction here. You can see some symbols different to the ones you thought you see over here. Also the engines indications here. We have maximum takeoff thrust right now. Autopilot flight director system panel. The other display here. I need to make a turn now, as you see. So we align with the flight plan here, this line, all the time as we fly. So you can see the stall speed again indicated with yellow. Increase a little bit the airspeed maybe. Retract some flaps. So we have the view here, beautiful view of the aircraft as we climb over here. So we climb through the lakes over here, the Swiss Alps, the Germany, my homeland, the Bayern Munich in front of you, and the France over here. So this is the Boeing 787. So we have a few more minutes left for going back home. 19,000. We have the Niglia here displayed as we fly on this side. The furthest waypoint over here. So we're gonna start the turn now. As you see, we can leave the hands off the flight controls. You see the aircraft is not falling down, it keeps climbing over here and here. As we make the turn, a bit faster turn now. We use a little bit right rudder as we turn, as you can see. So keep flying the hands off. The aircraft is turning on its own. It's trained properly, as you can see. Hands off, no problem for the Boeing 787. So we make a turn here, overflying Germany, Bayern Munich, France, also the lakes here, and the Swiss Alps. So hope you like the Boeing 787. Need also to align now with the flight plan as we climb. So we are here. We have also so we have maybe the handrails now leveling off here, as you can see. Keep climbing a little bit more. And we have the handrails, the frozen vapors from the aircraft, as you can see. And we're gonna start the descent in a couple of minutes. So we have the Germany, Bayern Munich, my homeland here, the lakes, the Swiss Alps, also the France, the galactic view, and the vapors from the engines. And a beautiful star sign over here. So hope you like over here. So you see. So hope you like the view. The Swiss Alps, how far above the ground we will be flying, how fast. We'll start the descent, the Germany, the France over here, the Italy this side, and we're going back for the airport. So we are at 35,000 feet. As you can see, we need to start the descent right now. So we start descending. We're following the flight plan, as you can see. Retract the flaps here and increase the airspeed as we descend. So keep flying manually, no problem with that. So keep having chemtrails here, descending. Also pitch strain on the aircraft a little bit, pitch down as we descend. Use some maybe speed brakes to increase the rate of descent. You can see a nicer view of the cockpit again as we are descending over here. So you have the complete flight plan here. We need to follow as we descend. Make a couple of shortcuts. You can see the runway here we use for takeoff and for landing. This is also displayed here in the navigation display, as you can see. So now we have higher max speed as we are descending. So keep descending. Hold the approach and landing of the aircraft. And we have 4 more minutes left. Idle thrust now. Need to keep descending. 1 more minute, then we make the turn over here. So now is the turn for the approach and landing, as you can see. You can see how we turn over here. So we need 3 more minutes for approach and landing. We need to follow this line again. Also a little bit more left rudder. More steep turn, as you can see. A bit more thrust. So we have the runways here. We need to align over here with the runway setting. Also use landing gear down now as we are approaching. And more idle thrust. Decrease a little bit the rate of descent. A few more flaps over here. Flaps and slots. Some speed brakes. So this is the approach and landing. You can see we are approaching for the landing part. So we are into the final approach over here. Hope you like it. We have some side wing, some wind gust, so we need to align the aircraft with the wind gust over here. With the runway heading all time, as you can see. So we have also the ILS localizer over here. the instrument landing system. We need to follow the Lszh localizer if we need. So we have a few more seconds for approach and landing over here. So align with the runway again. We have some wind gusts, some side wind, as you can see. So align with the runway. Over here we have the flare of the aircraft, pretty much. So is the flare, as you can see, touchdown, beautiful touchdown, and flare and parking brakes, and thrust, idle thrust over here, thrust reverse, as you can see, reverse thrust, and align with the center line. So here we are, parking brakes, thrust reverse there, and we're slowing down. We made a very beautiful landing over here, as you can see, very beautiful landing. All landing gear is perfectly fine. There is no breakage of the landing gear. As you can see the thrust reverse also here. We have reverse thrust. So align again with the center line. You see